Have you ever just looked up at the night sky and felt completely lost? I mean, it's just this endless sea of stars. But what if I told you there's a map? And what if that same map could also tell us the story of how everything, and I mean everything, began? Well, today we're doing just that. We're going to explore the cosmos, from how we find our way around to its absolutely explosive birth.
So those are the big questions, right? How do we possibly find our way around out there? And how did this out there even come to be in the first place? Let's start with the where, the cosmic GPS that astronomers use to navigate the stars.
You know, to most of us, the night sky just looks like this beautiful, chaotic splash of light. But for an astronomer, it's a meticulously organized map. And like any good map, it has a system. It's time we learned how to read it. Okay, so the secret to this cosmic map is this brilliant concept called the celestial sphere. Now get this, it's not actually a real thing. It's an imaginary globe that we pretend is surrounding our planet. Just picture a giant planetarium dome over our heads, with all the stars painted on it. This is the super clever first step to bringing order to the chaos of the cosmos. So in this model, we stick Earth right at the center of everything, with all the stars fixed in place on this giant imaginary ball. Now, as our little planet spins, the entire sphere appears to rotate around us. Of course, we know that's not what's really happening, but as a tool for mapping the stars from our point of view, it's absolute genius. But a map is pretty useless without landmarks and street signs, right? So how do we actually navigate this celestial sphere? What are the cosmic street signs that guide astronomers through all that darkness? Well, our first landmarks are the most ancient guides of all, constellations. I'm talking about Orion's Belt, the Big Dipper, you know the ones. For thousands of years, they've been way more than just pretty patterns. They are like these giant, familiar neighborhoods in the sky. If you can find a big constellation you know, you're already on your way to finding everything else around it. But for real science, saying something is, kind of near Orion just isn't going to cut it. We need a precise address. It's just like on Earth, where we use longitude and latitude to pinpoint any location. Well, the sky has its own coordinate system. It's called right ascension and declination. It's basically a cosmic grid that can pinpoint any object in the unbelievable vastness of space. And this is what that precision looks like. So instead of an astronomer saying, hey, look for that faint fuzzy thing next to that really bright star, they can just give these exact coordinates. It's a universal language that lets any telescope, anywhere on Earth, find the exact same spot in the sky. No guesswork involved. Of course, a map is only as good as your ability to read it. And that's where telescopes come in. You've got your optical telescopes that let us see things in the same light our eyes do. But then you have radio telescopes, which show us this hidden cosmos of invisible energy. And then you have space telescopes, like the Hubble, giving us these breathtakingly clear views because they're floating way above the distortion of our atmosphere. Okay, so now we have our map, we have our address system, and we have our tools to explore the cosmos. But all of this just raises an even bigger question, doesn't it? Where did this map even come from? To answer that, we have to journey back, way back to the very beginning of time itself. And that journey takes us to the ultimate origin story, the scientific story of how everything we see, every single star, every galaxy, every planet came to be. And that story, it starts with a bang, the Big Bang. I want you to just take a second and really let this number sink in. 13.8 billion. That's how many years ago our entire universe began. Before that one moment, there was no space, no time, no anything. And then, in an instant, there was everything. It's mind-boggling. So what is the Big Bang Theory, really? In a nutshell, it says that our entire universe started as a single point. A point smaller than an atom, but unbelievably, ridiculously hot and dense. And from that tiny, tiny point, it began to expand. And the most amazing part? It is still expanding today. Now, this is a super crucial point, because it's really easy to get this wrong. The Big Bang wasn't a bomb going off in space. It was the sudden, rapid expansion of space itself. Think of it like this. Imagine you have a balloon with a bunch of dots drawn on it. As you blow up the balloon, the dots all move away from each other, right? Not because they're crawling around on the balloon's surface, but because the fabric of the balloon itself is stretching. That's our universe. I know what you're thinking. A whole universe from a single point? It sounds like something straight out of science fiction. But the Big Bang isn't just a wild guess. It's a theory that is supported by a mountain of evidence. These incredible cosmic clues left behind like fingerprints at the scene of creation. There are three huge pieces of evidence. First, we can see that almost all galaxies are moving away from us. The light from them gets stretched out, or redshifted. That's the smoking gun that proves space is expanding. Second, we've detected this faint, warm glow all across the entire sky. It's called the cosmic microwave background, and it's the actual leftover heat, the afterglow, from that fiery beginning. And third, the recipe is just right. The amount of simple elements like hydrogen and helium we see out there today perfectly matches what the theory predicts should have been cooked up in the universe's first few minutes.
So as the young universe expanded, it also started to cool down. And as it cooled, gravity, the master sculptor of the cosmos, began to do its thing. Over millions of years, it just patiently pulled together these huge swirling clouds of gas, which eventually collapsed under their own weight to ignite the very first stars and form the first galaxies. And it was billions of years after that when our own sun and our solar system were born from the recycled stardust of those ancient giants.
So, from learning how to read our cosmic map to understanding the origin story of the map itself, you can see how it's all connected. One tells us where we are in the universe, and the other tells us where we came from. And together, they help us understand our true place in this grand cosmic story. What an incredible journey, huh?